Welcome to this quick video. Today I will demonstrate how BVQ can help organizations that are running IBM PowerVM systems, as well as IBM Flash storage and SAN, to easily identify bottlenecks in these different IT layers. And this is possible because of BVQ's key feature that allows to follow the data path, and it knows about the dependencies between the different components in the infrastructure, such as the IBM PowerVM systems resources, CPU memory, the adapters, as well as the OS level, also the LPAR or VM layer in virtual IOS, in addition to the fiber channel adapters and ports that connect out to the IBM storage and the SAN, Cisco, and Brocade. This provides great benefits to the IT teams, so they don't have to spend too much time looking through these layers to identify where the issues are coming from in the infrastructure. To give you a quick overview of the BVQ solution, it's an end-to-end analytics solution that also provides reporting and alerting. It supports many platforms. At the OS level, it supports IBM AIX and Linux. At the compute, it also supports VMware and Kubernetes. On the SAN side, it supports Cisco and Brocade switches, and also NetApp, ONTAP storage, and Dell EMC Unity. I will next show you the systems health map that gives you a quick overview of the health status of the infrastructure, and then I will show you the end-to-end monitoring dashboards. This is the system health map, where you can immediately see the health status of your PowerVM storage and SAN infrastructure. This is a multi-platform environment. It includes PowerVM, VMware, Kubernetes, Brocade and Cisco SAN, as well as IBM Flash storage, NetApp, and EMC Unity. I'm going to focus on the PowerVM area. The system health map is based on hundreds of alerts that you can easily customize, and I want to highlight that this new UI has been enhanced based on customer feedback, and now it's much easier to configure the alerts because you have more options to customize these according to your requirements for your environment. Here in the alerting area, you have this menu where you can see how for example, the PowerVM has alerts in the categories of configuration, performance, and system limits. You can easily enable or disable these alerts. And you can set thresholds based on the requirements for your specific environment. These help you follow configuration best practices for optimal performance. On the performance side and system limits, you can set threshold limits, for example, for system partitions limits or any fiber channel port free MPIV limits. On the SAN side, you have several key alerts that you can enable, such as port state error or port encoding errors. On the IBM storage flash system, it provides metrics on the capacity, configuration, performance. Let's go back now to the systems health map overview. Now let's concentrate on issues that are critical. So at the AIX OS level, we can dig deeper here and it'll list the errors. You can immediately see that there's issues with the volumes or the storage area. If we go into one of these, there are two errors: AIX disk path not enabled, and you can go into further details that gives a description of the issue and basically when it occurred. And in context, it gives you also or lists the errors that are occurring in other volumes as well. We can also immediately see that on the storage side, the issue is about the host port state not being optimal. Again, let's look at the details. You can see where the issue started happening and other objects or ports in the system that are experiencing the same issue. If we go into more details by clicking on the port, here you can see that it also gives you information about of other components that could also be affected and gives you context about this issue, such as the flash system I/O group or the cluster itself. You can also see the performance of the volume or V disk that is using this fiber channel port on the flash system. It shows the I/O rate and latency or response time. You can look for peaks in the response time that will indicate that this has occurred due to the issue with the host port. Next, I will show you the end-to-end monitoring dashboards. This is the monitoring dashboard. This specific dashboard shows the PowerVM system's resource utilizations, CPU memory, virtual SCSI data rate, virtual fiber channel data rate, network, and also the system temperature and energy consumption. There are several monitoring dashboards that you can choose from. On the PowerVM side, you have the end-to-end performance. Then you have specific performance views for the LPAR. At the OS level, you can go deeper for the AIX or Linux. And at the system level performance, you can also use a specific dashboard here. I will now go into the end-to-end performance dashboard. At the top here, you can select a specific HMC, system, or LPAR VM, or group of VMs to monitor. I will select this system and this LPAR. Here you can also select the time frame to show the performance views. You have options from hours to days or months. Depends on how much data or historical data you want to maintain. This dashboard includes key metrics that will help you understand the workload performance characteristics. I would like to focus on a few of these, for example, on the LPAR core, the run queue, processor pool, and the rperf metrics. The LPAR core's performance view. This gives you an overview of how the cores are being utilized and compare that to the cores that are entitled to help you easily configure the system for the right entitlement amount. Next, I would like to highlight the run queue performance view. This shows the processes in the queue that are waiting for I/O. If any of these processes exceed this threshold red line, then it's a good indication that the CPU configuration needs to be adjusted because the CPU resources are not enough to handle the current workload. Next is the processor pool usage view. It shows how each VM is affecting the usage of the processor pool. It shows the configuration assigned and utilized. Next, I would like to highlight the rperf. The rperf value is calculated and it's shown by BVQ here in this performance view. The rperf value is useful when sizing for a new VM or system, and you can compare the rperf values of the old to the new system. As we go down here, we can see the disk usage, disk throughput, and disk IOs, as well as the network throughput and network packets dropped. Now we go into this external storage, and these are the performance views of the volumes that are servicing this particular VM or group of VMs. The metrics shown here are the data rates, volume I/O rates, and latency or response time. If we hover over the peaks, you can see that all of these metrics are correlated easily by a vertical line. This way you can easily identify when there are peaks in performance during a certain time. And you can easily zoom in into the particular area. I want to highlight that also it shows the disk adapter data rate, I/O rates, and latency, as well as the virtual fiber channel metrics. Now we go into the SAN, the external SAN that connects the PowerVM system to the storage. And here you can see the fiber channel switch metrics, so at the fiber channel switch level. This dashboard also includes the PowerVM Virtual IOS components, and you can see the resources for usage, entitlement, memory usage for this particular virtual IOS. I hope you found this information useful, and as a summary, you can easily detect bottlenecks in your PowerVM systems environment because BVQ gives you that ability to follow the data path and identify issues in all of the IT layers, the storage and SAN. Thank you for your time, and contact us if you would like to try BVQ in your environment.